We're becoming more recognized in the residential space, but we bought Square D many, many years ago, and that's probably a more recognizable name to everybody here. But yeah, now that we've been in the solar with storage space for quite a few years, people know who we are, but we definitely want to become more and more recognizable as we go forward. So we've got over 30 years of experience with solar with storage, and that is because Xantrex was purchased by Schneider Electric in 2008. So we had all the experience from the old Trace SW that kind of carried forward. So all of that tribal knowledge also is within the industry as well. So we've seen a lot of changes in the industry. The true sine wave inverter that we get out of the Pro is much more true than the old Trace SW, which had observable steps in the waveform. We pride ourselves with industrial strength and durability. We still have systems, thousands of them, that are going strong after well over a decade, which is when the XW first came out, the legacy model. We have very, very low failure rates. It's a super reliable product, and we also have world-class support for our products as well. So just a step back in time, XW was released in 2006. It was the first 12240 volt dual input inverter on the market, pure sine wave. In 2014, we released the XW Plus, which added support for AC coupling and multi-cluster. And then now we have XW Pro, which has a completely new and redesigned control board to comply with UL 1741 SA and now SB coming up. It has a 10-year warranty. So the basic design, the transformer low frequency design, is what gives this such incredible power. Utilizing the transformer helps with starting inductive loads, and it also helps with line imbalance. So it's not something that's prone to nuisance tripping like a high frequency transformerless topology. So XW Pro features and benefits. It prioritizes stored energy. It has a virtually seamless transfer. Toroidal Transformers offers best-in-class surge capability. Dual input means that you have AC1 for grid-related functions, AC2 for generator-related functions, compatible with many different storage solutions out there. The altE HAB battery, you can see we've got the XW Pro demo connected to it. I invite you to stop by the booth and we can talk a little bit about how that is configured. It's actually kind of cool. We got a tablet set up there to offer a continuous display. And then of course we can be AC coupled or DC coupled, so that lends to the versatility of the product. And then we're scalable up to 25 kW in single phase, which is equivalent to 4 XW Pros. And there is the tail of the tape. So we have a 6,800 watt continuous at 25C, 8.5 kW for 30 minutes, and 12 kW for a full minute, which is really an incredible surge capability for starting problematic loads and to assist in line imbalance. We're able to enter the overload band and stay there for a period of time. That is what allows us, it prevents the system from nuisance tripping. So the design of this product, what adds to its longevity is the fact that we have a completely isolated compartment for airflow in the back, and it draws air across the transformer and the heat sink, so we don't expose any of the critical components to dust or any foreign material that can compromise the lifespan of the product.
Is that filter cleanable, or?
So there is a foam filter in the back, on the bottom, and it can be removed so you can clean it. But it's an indoor rated product. I'm really not aware of too many situations where somebody's had to clean it, except for I visited a site where the Amish had a wood shop, and it was really damp in there, and it drew wood into the foam, and it blocked it. So
Is there a fan that forces that through there?
yes, there's a fan on the bottom, and it draws air through the bottom, and then it exits out the top. So don't put the manuals on the top. We've seen it before. All right, so continuous output again is 6.8 kW at 25C, and then as the ambient temperature increases above that, we have a linear derate. So make sure that you take account of the hottest temperatures in the summer that the system is going to be exposed to. And then, the toroidal transformer is more efficient than EI transformers, offers less noise, superior temperature range, allows continuous starting of inductive motors without a drop in performance over time. The line-to-line surge capability is shown here. The real benefit comes in the line-to-neutral surge capability. So this means that you can have either L1 or L2 operate up into the overload band for a period of time. So on a single line, we can surge 12 kW for a minute. We can power 8.8 kW for 5 minutes, 6.3 kW for 30 minutes. So as you increase in wattage, you are operating that wattage for shorter and shorter period of time, up to 12 kW. So that gives us the forgiveness that's required when customers are turning loads on and off, and they might enter that overload band. And what would cause competitors' products to nuisance trip is no problem with the Pro. It'll allow you to stay there for a period of time. And a lot of appliances, if you think about them, don't stay on that long, like a hairdryer or a microwave, things that might get turned on and put you up into that overload band and allow you to operate that for a few minutes, right, without nuisance tripping. That's where the challenges come in for high-frequency transformerless inverters, and that's why you have to have smart load centers. That way you can prioritize what you can do without, right? With XW, it's more robust. You don't have to do without, If you have loads, challenging loads, I've seen this thing start a Makita chop saw while powering 9.3 kW on a single unit. So it was already operating in the overload band, and he went ahead and started a chop saw with a 67 lock rotor amp rating. So things like that are these incredible situations are situations that a homeowner could really have, and they do have, especially when they have tools and whatnot.
You covered it, but I didn't quite understand. How much can I put on a 120 load as opposed to a 240 load?
So if you're just running a single line, we can run 4.8 kW continuously at 25C. We can run 6,300 watts for a half hour, 8.8 kW for 5 minutes, and 12 kW for 1 minute.
On one line?
On one line. That's right.
So what happens when you exceed that? Is that going to trip off, or is it going to fail?
You're going to get a warning, an over W63. You're going to get 2 warnings, and then if it happens again, and it's going to happen like within 30 seconds of one another, 30 seconds to a minute, after the third one, it's going to turn into a fault, and then it's going to shut down.
Okay. I want to make sure it's protecting itself.
Yeah.
Do you have the 2 XW Pros that I've done? Neither one came with the old one, the control panel on the front, and I had to order that separate.
So the user interface, there's no reason why you should have gotten an XW without a user interface. They all come with them, and they have for many, many years. That particular piece hasn't changed. Oh, the system control panel. We're going to be talking about that when we cover monitoring. Yeah, and you're right. The system control panel has been discontinued, but we have a better solution. I hope I'm going to be able to convince you guys of that.
Yeah, right.
But no, I'm serious. The system control panel has severe limitations when it comes to the Pro, and we'll talk about that in our monitoring session, either later today or tomorrow. All right, so I just wanted to cover the complete family of accessories for those of you who are not familiar with the XW Pro platform. So we have actually 3 models of solar charge controllers. We have MPPT 60, which is a 150 volt DC max on the PV side. It provides 60 amps to the battery with an appropriately sized array. We have MPPT 80 and MPPT 100. Those are our high voltage charge controllers. They operate up to 600 volts on the PV side. We have Insight Home and Insight Facility for monitoring. And then, of course, we have Insight Cloud for remote monitoring, Insight Mobile for monitoring through your mobile device. We have our Connects battery monitor for those of you that want to run lithium iron phosphate open loop, or if you have a lead acid battery, that way you can take advantage of state of charge control functionality. And for balance of systems, we have our power distribution panel, full size, which is appropriate for a single inverter, but you can expand up to 3 inverters. And then the mini PDP, which is appropriate for single inverters. And you can see we have a mini PDP mounted under our demo unit out there. We have the config tool, which is really going to be obsoleted out. The next firmware revision, we're going to have calibration built into Insight Local. So the only other thing now that the config tool is good for is saving configuration files. And eventually that's going to be built into Insight Local as well.
Can I ask, I thought you could only have 2 XW Pros, and you said you could have 3.
4. You see, the thing is the full-size power distribution panel only has 3 positions for 250 amp DC breakers. So when you get up into quad stacks, then you have to have 2 PDPs if you want the complete balance of systems. There's other ways to get around it too, especially with the backup control switch. We're going to be talking about that here in a second, and that's basically what this whole session is going to be about. But I wanted to give you guys just an overview of our product lineup for those of you that were not familiar with it. Our Disconnect RS provides arc fault and rapid shutdown, and it's compatible with Tygo fire safety receivers. And then last but not least, we have our automatic generator start. Oh, and then of course we have our backup control switch, which is out there in front of our table. You can check that out at your leisure. It's a simple solution. It's our own solution for external switching. So as you guys are probably aware, each XW Pro has a 60 amp breaker internally. So when we're switching more than 60 amps, then we need to start looking at switching externally. Up until now, we've used third-party products. ASCO is owned by Schneider. We've used ASCO Series 185, Series 300. A lot of people have used Generac, just dumb transfer switches that, they switch to the secondary position when they lose their primary power. But now we have our own solution here. And what this does is it avoids overloading the 60 amp relays that are built into each inverter because they don't all close their respective internal relays at the same millisecond in time. And so if you're switching more than 60 amps, the one that closes first is going to get the total current across it. Even if it's just for a fraction of a second, it could weld that relay shut. So for the longevity of the system, we want to start switching externally when we're switching more than 60 amps, which at 240 volts is 14.4 kW. The 200 amp rating, it's a service entrance rated device, so it's a 200 amp rated device, although you can buy main breakers that are smaller than that. If you wanted to back up, say, a 100 amp panel or whatever, you can certainly do that. And then, typically, triple stacks and quad stacks would require the backup control switch, but you could, use one of these with a dual system if you wanted. But a dual system is pretty well suited for a 60 amp system, so you really don't have to have external switching, but it might provide ease of installation for a whole home backup to use this device. So it's approved for UL 1741 grid interactive applications, UL 67, UL 869A, which means it provides touch safe barriers for service entrance rating, and it is service entrance rated when a main breaker is installed. It does have a bonding screw for bonding your neutron ground together. It's FCC Part 15 Class B compliant for noise EMI levels.
So it's a 1741 SB.
So the SA and SB is the inverter part, right? This is just a switch. And then here you can see the internal workings of the product. So we have the actual 200 amp switch here, and this is the lever for the internal bypass. And then you have your bus bars here, and then you have the socket where you could mount your main breaker if it's needed for service entrance rated, and these use the Square D QOM 2 series, and you can get those in 100 amp, 125, 150, 175, and 200 amp models. We have a DIN rail here that you could use for a non-backup panel if you wanted. We have really large lugs here that can accept from number 4 up to 300 kc mil cables. Oh, larger than 4/0, for sure, a lot larger. And then, of course, you have 2 lugs per line, so you can do line side taps like for AC coupling to get around the 120% rule, things like that. So really well thought out product. And then here we have our PC board for the aux port. And then up top we have the watt node meter with CTs. So you're going to be able to, when we're switching externally, to be able to see how much the load is, we have to use the CTs, right? Because we're doing it, we're no longer passing the load through the XW with this product. So keep that in mind.
So that's just a switch. It's not a transfer switch, correct?
It is just a single point of connection contactor, right? A transfer switch has a common side and it switches between 2 inputs. All this does is it just brings an external source of AC into your AC bus. All right, so XW Pro is the hub, PV storage.
Just a minute before we leave that, does that, that allows me to monitor the total grid, the total mains of the building? Mm-hmm. And I can somehow control my XW Pros to put power in. I'm looking for demand compensation.
Right.
That can do it.
You can, yeah.
Okay.
Yeah, we have the zero self function that you can use for self-consumption, or you can program it to only draw a certain amount from the grid. If you have, demand response where you get above a certain level, you have all that programming available to you.
Is that programming in that device or is it
In the Pro.
in the Pro?
Well, it's actually used in conjunction with Insight Local. So you have the Smart Energy Manager built into Insight Local, and that takes the watt node meter up at the top, and it considers what's being reported by the watt node meter.
Okay.
So here you can see a typical system where you have your grid coming in, your self-supply meter can be mounted upstream here, and then your main panel. Now this is typically a system where we're passing through, right? This is how it is now. If you are not required to install an external transfer switch, like with a dual system, you don't have to have the BCS, which is the product that we're talking about here. BCS 2200 is the part name, the nomenclature, and we just call it the backup control switch. So this is a diagram of using an ATS, right? Up until now, we've been just having our grid come in, and then we have the ATS, which it feeds the backup panel directly, and then to mitigate the demand from the grid, we just export through the input, right? And then if the grid goes down, we switch all of the load to the output side of the inverter, and that protects the internal transfer relay. And then here's another diagram that shows how that works. So the grid is coming in, we're offsetting the demand by exporting power onto the AC bus. The grid goes down, boom, we shift all the load to the output side of the inverter, and we're protecting the transfer relays this way. And then if you're on grid with a generator, it would require 2 ATSs. And so if the batteries get low, then the generator starts, and the generator charges the battery, and it also supports the load directly. So here we see a diagram that represents how the backup control switch works, and it's much like the Tesla Powerwall, where we have our AC bus that is continually keeping the main panel active, and then we qualify the grid to allow the grid to come into the AC bus. So that's done with sensing wires. And then we also have that DIN rail position where we can add a non-backup panel if we wanted to do that. And then you have the 2 lugs for each line where you can do a line side tap for an AC coupled PV system if you wanted to.
I'm sorry, I might help you solve some more of these, just bear with me. Can that be our emergency disconnect means, like, can we, instead of, when we're doing a service change, instead of having to get a meter main, do you know if anybody's accepting a button outside adjacent to the meter that's gonna kill power inside, and then obviously we gotta go to overcurrent protection after that, right? You follow? Because anybody having trouble getting
I
meter
think
mains?
the question, in my area, the utility requires a visible blade disconnect on your solar system so that,
Well, this isn't on solar, this is on a service change now. You need they want an emergency disconnect, code's calling for an emergency disconnect, not solar. This is just before you get inside.
You could have an emergency.
This could-
You could have an emergency disconnect upstream. All that.
He's asking if that would qualify as your
I
emergency
don't think
disconnect.
it would, because then you can't get into your system unless you have some means of disconnecting from the meter, in between the meter and that, right?
I don't know.
Unless you want them to come pull the meter.
Well, if they hit the button,
Yeah.
power's shutting, actually, it is going inside the house, right? They want it shutting off outside the house, I
Yeah.
suppose, because these are only rated for indoors, right?
These are outdoor rated. The BCS is outdoor rated.
It is.
Yes.
Can you how would you shut down power coming through the BCS?
You would have to shut down the power that was being sensed. We have the 2 sensing lines, right? So if you interrupt those sensing lines, it'll shut off
that
the
out.
power.
So
Yeah.
we hit a regular meter socket, we have that next to it, that gives us our line tap, it gives us our emergency disconnect.
Yeah.
From there, we go inside, hit our overcurrent protection, and do all this other stuff.
Yeah.
as long as your inverter's
Yeah,
I gotta think that this is gonna have something that's gonna interact with your inverter and shut that down too, wouldn't it?
Well, we do have the RPO, which I'm using on my system at home, which uses pins 2 and 3 of the aux port. So if you have RPO enabled and you create a short across pins 2 and 3 of the aux port, it shuts the XW system down. And that would also open the backup control switch too, because the inverters have to be active in order to send a signal. Because what the sensing lines are doing is allowing the XW to synchronize its own grid forming with the incoming, so that they're zero cross, right? So they're completely in phase. So the RPO should also open up the BCS.
And we're referring to, what, 230/85 or something like that?
The new
Where
requirement that you have
Yeah.
on new services,
Yeah.
that you have to have an outside
Yeah.
disconnect.
Yeah, no,
Can
that
that be used as that?
Doesn't have
That's-
to be overcurrent
no-
protection outside.
Right.
No.
I fought that through my state, and I've lost every time. They say, no, you have to have an external mechanical disconnect.
On the solar, yes, this isn't about
No,
solar.
not on the solar, on the new service, or service
Oh,
upgrade.
really? Was it Vermont?
Yes, 230/85, I think.
So this represents a quad stack. So assume we're using 2 power distribution panels. We are interconnecting, the power flow is connecting to the AC1 port of each inverter. And then on the master, we're using the AC2 port for sensing. We don't have to have sensing for the following inverters, the slave inverters, just the master. So we run 2 number 14 from AC2 to the backup control switch, and the fuses are already in the backup control switch, so all you have to do is land the wires. So once the AC source comes in, we sense it. That gives the XW Pro system a chance to synchronize with it, and then when they're in phase and after the transfer delay, which is a settable function as well, is expired, then it'll go ahead and send a signal to close the contactor in the backup control switch.
So that picture, Eric, you are your AC input, you have an external ATO transfer switch if you are using grid as well as a generator?
Yes, great question, Tom. So, yeah, we are using up the AC2 port. So if we are on grid with a generator, we still have to have an ATS upstream to select between one source or the other. But after that, it's just a matter of programming, right? So you're not selling back to the generator. And we can talk about that offline, but, you know, it's definitely doable with the platform. We have all the settings we need available to us in the Pro to use it for on-grid with a generator. So each PDP can accept 3 250 amp breakers. That's why when we go to a quad stack, we have to have 2 power distribution panels, but there are other ways to get around that as well. I think I lost my...
Is the BCS, is that on the ZAN bus?
No, BCS is not on ZANBus. The only connection that we have to the BCS is from the aux port of the Master XW Pro to that circuit board that's in the BCS. So
Is
this,
there a way to monitor that online, the position of that switch?
well, yeah, you'll be able to see whether the system is in backup mode or not, because it'll show you whether if you have, right, it'll show you whether your grid is coming into the system or not. You'll be able to see it. So this represents a system where you might choose not to use power distribution panels. And this came up with a customer, he didn't have enough space on the wall to install power distribution panels. So basically what you can do here is install a wiring trough and then run out to each inverters can use a 35 amp breaker, because remember, we're no longer passing through the inverter anymore, so we don't have to account for the load plus the charging that would be required. So we can never put out more than 6,800 watts continuous in either direction, right? Because we become a bi-directional system with the backup control switch. So that means we can get away with smaller breakers and smaller conductors between the main panel and each XW Pro. And then of course, for balance of systems on the DC side, you can use a midnight battery combiner, right? So this is just this is an alternative to power distribution panels if, say, you don't have the room for 2 power distribution panels and you want to do a quad stack. And then of course, we have the ability to do line side tap with our AC coupled PV. And then here we have, you know, if you still have to get around the 120% rule with a DC coupled system, you could install a small breaker box that could house for 35 amp breakers for each XW Pro, and then just, you know, do the line side tap on those as well. And then of course, there's plenty of positions available in the midnight 1000 amp battery combiner to also include, you know, 6 MPPT 100 charge controller breakers. And then of course, we have the ability to connect a generator. Instead of, like, if you're off grid, you can certainly use the backup control switch with a generator and our automatic generator start module that will only start the generator when the batteries get low. So if you're off grid with a generator, just make sure that you don't enable the cell function. And then AC coupling.
Does that do state of charge?
Yes, it does. If you have our battery monitor or a compatible battery like the HAB out there, then you'll have state of charge control.
Okay.
Great questions coming in. I love it. All right, so this represents a system where we're running off of the PV, but our PV is not able to keep up with the load, so we just discharge the battery. Now we've called upon our generator to start, and you notice we have an interlocked relay here. That is to prevent the AC coupled PV from turning the generator backwards, because it's not going to appreciate that. And then, you know, we sense the generator, and then we close the backup control switch to bring it in, get the battery charged up, and then we'll stop the generator, at which point we'll go ahead and you can see the batteries charging there on the left, And then once we get to the stop criteria, and it doesn't have to be a full charge either. You can partially charge, you can choose to partially charge the battery, and maybe by then the clouds will have rolled away and you'll have some PV to work with. And so for the interlock, you can use one of these models of contactors that has 2 normally open and 2 normally closed positions. So that way, when it's energized from one line of the generator, it has a 120 volt coil, then it'll go ahead and bring the generator power through to the BCS, and then it will also interrupt your AC coupled PV.
And you're installing that in your BCS? You're installing that contactor in your BCS, or is that external?
It would be external, yeah, you know.
Just indicated you had the DIN rail in there, and I was just wondering, that's important, so that's fine.
Yeah, I can see this one looks like it can be mounted on a DIN rail, and I don't see why you couldn't do that, right? You're within an enclosure. It should be perfectly legal, and
What's the space of your DIN rail? Your DIN rail,
yeah, I think it's out there. It's like 4 inches. I'm pretty sure it would fit. If not, you can install a box outside to mount it in. You could even put it in the PDP if you chose to use one. So here we have, looks like, okay, so this is a grid connected system, right? And when the grid's available, we sense it, synchronize with it, and send a signal to close the backup control switch. And now at this point, we are grid interactive. If there's any excess PV after the loads are satisfied, we're going to go ahead and export that back to the utility. When the grid goes down, we're going to be running off battery and PV. If the PV cannot keep up with the load demand, we're going to be drawing out of our battery. If the batteries get low, then we're going to go ahead and call on the generator to start, and that's going to isolate your AC coupled PV and bring that generator power into the AC bus to get the battery charged back up, and then stop the generator, and it'll continue in that vein until the grid comes back.
Does the XW Pro provide any smoothing signal for the generator?
No, it's not a grid conditioning type of a system or an AC conditioner, right? If it's got dirty power coming in, it may accept it if the voltage and frequency are within range, but then at that point, you know, you're going to be powering the loads with that source, right? At that point, the XW can add current to the line as a current source, but the grid forming goes away whenever we qualify an outside source of AC. These are good questions. Yes, sir.
So, with a system like this where you have grid coming in, you have your generator and you have your battery system, I'm sure it's easy to do, but in the programming, can you ask to use battery during the evening, even if there is AC power coming in on a regular basis? Just if rates go up, our rates in Maine are going up at night. So I have customers asking about, can I use my batteries overnight or a portion of my batteries overnight to offset
You could.
some of the usage?
You could. We do have a cell block function where you can block selling during a certain period. So you could, if you flip that around, you can export during a certain period of time. Yeah, there's a lot of programmability.
Or just, not even export, just use that, if
With
you
the cell supply, yeah, with the watt node meter, absolutely.
Use 50%, of the power needed in the home coming from your batteries and 50% from the grid or something like that.
Yes,
Okay.
absolutely.
It's got the same old generator support function though.
So generator support means that we are supporting the generator with battery power. Usually when the generator is called upon to start with our system, it's because the batteries are low, right? So you can't support a generator and charge the battery at the same time. You're starting the generator because the batteries are low. You don't have any stored energy to work with at that point.
Yes, but I'm in the case if I go to the generator and I have a surge come in, well, my and I have partial battery. Mine, the one of my, yeah, I have too small a generator, and I.
Yeah, you got to be
limited
careful with,
generator
you got to be careful trying to integrate a generator that's too small into your system, right?
input.
Because,
The customer's got a generator that's too small, and he wants to use it.
well, yeah, you're going to have to be careful. And I can help you with a design like that, but you have to consider that usually with our AGS, you know, we call on the generator to start because the batteries are low. That means when the generator is qualified, we're not only carrying whatever load is present, but if we want to engage the charger, then that's going to require that much more from your generator. So, you know, like I said, you can't support the generator with battery power, which means we're discharging, and charge the battery at the same time. It's, you know, they're antithetical functions.
Or use a different inverter charger. He could have he could put the small one into battery charging only with its own charging system and not using the charging system in your inverter, couldn't he?
Well,
Not with their automatic transfer.
yeah, you know, when the generator calls upon to start, again, if you look at the diagram here, we're feeding that load panel directly. So the load is going to be whatever it is. If the load is too much for the generator, if the generator is too small to pick up the load, then, you know, that's going to be a problem. You need to make sure that
the small generator with only battery charging as its only load.
Get a battery charger.
Just dedicate it. Act
Oh,
as
I
a
see what you're saying. Yeah,
battery.
yeah, you could do that.
Then
You
the
could do-
customer feels like it's being useful.
Eric, does this scenario require the AGS and your Insight Home to perform all those functions?
Yeah, so Inside Home is required because it allows you to enable the external transfer function.
Anything you're doing with this,
You have to, yeah. You should never install XW Pro without Inside Home or
Does it require the AGS also to control the?
for the generator. Yes, I mean you could use the aux port of one of the slaves, but you know the nice thing about the AGS is it allows you to program the cool down cycle. A lot of times you want to let the generator run for a period unloaded before you actually stop it.
Quick question, if you've got an AC coupled inverter on a sub panel, on the load, on a single inverter, is it still okay to take a generator input into that single, charge the battery, and keep the...
Yeah, that's the thing. That's a good question. I mean, whether we're qualifying on AC1 or AC2, if the load is on the output side of the inverter, then the inverter is just passing that power directly through to the load. So if there's AC coupled PV on the output side of the inverter, that's going to be, the generator is going to be exposed to that. And the XW Pro is not going to have the ability to limit that AC coupled power at all, because it's just passing through. Make sense?
generator manufacturers don't appreciate backfeeding their,
No, they don't appreciate it at all. If you're going to AC couple with a generator, you need to have the contact, the two normally open, two normally closed contactor to isolate the PV anytime the generator starts. And that's why I say you don't have to.
Even if it's on the AC2 input?
Exactly. Exactly. And that's why I say you don't have to run the generator till the batteries are 100% full. It might even be more beneficial to you to only partially charge the battery, and maybe by then the clouds are rolled away and you'll have some PV to work with. So here we...
So his question is about a AC coupled solar. Will the XW export on AC2?
Well, yes, because the AC coupled power is, you know, if this switch is closed here, well, I'd have to show you a diagram of, let's go back to one of these where we're actually passing through the inverters. Let's see. Okay, so if this was a generator coming in on AC2, okay, here we go. here's our generator. So when the generator is qualified, and let's say I had grid and I had AC priority set for AC2. When that generator starts, it's going to drop the grid, it's going to qualify the generator, and then that generator power is going to be powering this load panel, which in turn is going to be supplied with current by the AC coupled PV. So if your PV power that's being generated exceeds the watts in this panel, then that current's going to go back to the generator.
But didn't you say a moment ago that your inverter is not grid forming? So-
Not, not when we're qualifying an external source of AC, whether grid or generator.
But
We're
when
not
it
grid
is-
forming
when
anymore.
There is no grid. It can grid form and trick your microinverters into turning on.
Exactly. Yes, that's
And-
the only
and How
time.
does it moderate that? Is it still the sledgehammer approach that used to be in the early days, or how is?
So we have the frequency shift algorithm. So once we either get to the program's voltage limit or state of charge limit, you can use either one. Then it'll go ahead and shift the frequency up to kick the PV inverter offline. If it's a UL 1741 SA approved PV inverter, then you'll have the frequency watt function as well as the ramp rate that you can use to kind of tune the system into how you want it to behave in a backup mode.
Could you, is there any setting or possible to do an option to have your AC to only charge the batteries instead of going to the AC output? Or should you just get a battery charger and plug it into your generator? Keep it completely isolated?
Yeah, I'd have to. I'll give you my contact information, and then we can knock out whatever your design question is. So this would be a system where we had the watt node meter and the CTs, where we can program the system to only export from the battery or from our DC bus what would be required to satisfy that load panel there. So in this particular case, we could have a system that was connected to the grid that sold to the grid when the grid was present, but did not sell to the generator because we have programmed our grid support SOC is greater than the stop SOC for our generator. So whenever the generator is running, it'll never allow us to get to the level where we're going to enter grid support and start exporting. All right, so this is all accomplished through programming.
So, I'm sorry, go ahead. Oh, if like the customer manually started the generator, but the batteries were charged, could it then, and the utility was out, sell to the generator? Even if, right, yeah. So it's not a guarantee, it would just be a function of,
The only guarantee would be your contactor disabling your feed to your AC coupled system.
Yeah, you have to be careful with that. You'd have to make sure that, you didn't, and why would you manually
well, I
start the
mean, customers
generator?
do
Well,
stuff, man.
so
I mean,
this actually goes with my question. So a lot of these generators have, they have general maintenance where they turn on at a certain period, at a certain time, and most customers want it at like 2 o'clock in the afternoon. And on a bright sunny day, your batteries are charged and you have power coming in from your PV. That's gonna,
Yeah,
your generator's gonna start automatically unless you're a programmer there.
yeah. In that case, I would make sure that we use the quiet time to make sure that we're not allowing the generator to start during solar hours.
But I would be careful with that setting, Eric, because in the event that the batteries are low, that's gonna override your quiet time. So essentially, the only way that realistically you can eliminate that possibility, generators are expensive, and anytime you connect them to a system, in my case off-grid, you're shit out of luck. So a contactor to me seems to be a very inexpensive way. My SMA stuff, I was able to program the amount of backfeeding into the generator. The newer generators with all the electronics in there, they are far more nervous about that, and the boards are a lot more expensive. So to me, it just seemed maybe that's something that Schneider wants to put together is a simple.
Yeah,
with the contact room.
I would say that, in a situation like that, that you would want to enable the zero cell function.
We used to, years ago, SMA required you to, in the event that you had a generator, it was upstream of your transfer switch. Your AC coupled system, your AC coupled inverter would be upstream of your transfer switch. So that would disable your AC coupled
Yeah,
system.
well, always we want to have that interlock for an AC coupled system because the XW can't do anything about the AC coupled PV. But this is a DC coupled system, all right? So in this particular case, if you're, you might want to just go ahead and use the zero cell function so that way you never stand a chance of selling back to the generator. But then under those conditions, you wouldn't sell back to the grid either, right?
Isn't there a way to program that? If you're calling for a generator, you call for zero sellback, and if you're connected to the grid, you allow sellback.
Right, no, there's not, because we're using a single point of connection, which is AC1, we have to be careful in our programming to make sure that we're not selling back to the generator. That's why I said we have to make sure that our grid support SOC is higher than the stop SOC, so we're not allowing the generator to be exposed to any cell power. But again, if you're using the watt node meter with the CT, it's not going to sell anyway, whether we're connected to the grid or a generator, right?
I would think there'd be a way of telling it, hey, I gotta have a generator, I don't wanna sell back. Hey, I got grid, I wanna sell back. And I don't have to go and switch something. I just
Right,
have it programmed in there.
Yeah, there's,
What's the number 2 port doing? You mentioned this is
the number 2
one.
port is used for sensing only, on the master, right? So the master is using up the yellow line there for sensing your external source of AC.
When it wasn't doing it for sensing, isn't that where we used to put the generator?
Right, so if you have a single or a dual system, you can use AC1 and AC2 separately. If you have a split bus panel, you can also use AC1 and AC2 separately and feed the upper portion with 2 inverters and the lower portion with 2 inverters. That way you don't have to have an external transfer switch. Schneider Electric is coming out with an energy center that has a split bus panel. Split bus panels are making a comeback, and those are especially useful in situations where you want to go ahead and pass through and have the full functionality of generator and grid with XW Pro. And that way you're getting around the 60 amp limitation because you're splitting up 2 and 2, right? You have loads for the upper portion of the split bus panel and loads for the lower portion. So you can feed the upper portion with 2 inverters and the lower portion with 2 inverters. So there's a lot of versatility here. There's a lot of different things that you can do with the XW Pro platform. And I'm here to help you guys figure out how to get from point A to point B with your design. And designing around the needs of the customer, I believe, is the path to success, because in residential solar with storage, one size does not fit all. You have a lot of different requirements depending on the homeowner, right? To just go in and say, oh, I want solar with storage and just slap it all in one. That might work for a great percentage of people, but there are certain customers that have very specific requirements, and if you just slap an all-in-one in there, you stand the chance of having some problems without doing a careful load assessment of what's going on.
At 2 o'clock in the morning.
Yeah, and another thing too that, because we have the track record of longevity, after 5, 10 years, these things are going decades, and they have a track record of lasting decades. If you're the installer and you have a problem at year 8 or year 9, and it's still in warranty, if they have your number, you're probably going to be the one that's going to get the call. And what you don't want is to end up with a bunch of warranty work down the road because you're working with a product that hasn't proven itself in the test of time. This here shows us a way to use the ASCO Series 300 to inhibit transfer to an emergency. it's just another way of protecting the generator from backfeed. I can talk a little more about that offline. It kind of gets a little complicated. And we're at the top of the hour. We're probably pretty close to being finished here. So MID, a microgrid interconnect device, that's what the backup control switch is. It allows us to bring an external source of AC, whether grid or generator, into the AC bus. And then, of course, we have the optional position for a non-backup load panel. And
Is there a way of getting some of these slides, I'm a slow learner, so that I can review them?
yeah,
The slides are.
I can make a PDF for you.
Or ask altE to
Yeah,
make them accessible,
yeah,
or have their presentations accessible from altE that we can get from their
yeah,
resources.
yes, yeah. We can. As a matter of fact, these are NABCEP eligible, so I'm pretty sure you can get them through NABCEP because I have to turn these presentations in to them.
NABCEP doesn't do that.
They don't.
Well, I don't know for sure. but
We'll figure out.
representatives
We'll get you what you need. All right, but you guys have been a really great group, and I want to thank you guys for allowing me to share with you today. And stop by the booth if you have any questions, and I'll be happy to answer those for you. Enjoy the rest of your time here.